Here we're going to talk about the atmosphere. We're going to start talking. This is our last section of the course, and this video is just a little introduction to atmospheric pollution all the way from the past into the present. Right. Okay, so humans have been altering the atmosphere for at least the last 2,000 years. And 2,000 years ago, we can actually pick up a signal in the atmosphere from methane production from civilization at the time. So you can see in this article over here talking about air pollution being a problem since the days of ancient Rome. So what was making methane at that point? We think that it was cows in Rome and rice in China. Okay, and this is one of the first laws against air pollution. King Edward I decreed the death penalty for burning coal. Didn't actually go very well. There was only really one recorded offense in one execution anyway. But in general, nobody really stopped burning coal, and the penalty became much softer over the years. So we've been changing the atmosphere and its chemistry much more dramatically since the 1700s, the late 1700s, with the Industrial Revolution. And these are pictures from London, and they had a giant smog event that I'll talk about in a little bit. Or just now. In December 1952, there was a 4-day smog in London that was sort of a combination of coal burning and fog that happens in London quite frequently. And those two things combine to actually make little droplets of sulfuric acid. And we'll talk a little bit more about the exact chemistry about that later on in the class. But about 4,000 deaths, so pretty dramatic event. Then in October 1948, there was a similar event with 20 deaths in Donora, Pennsylvania. Again, a result of coal burning and fog. So as a result of these really dramatic air pollution events, the US anyway, and England came up with these Clean Air Acts and amendments in the US and automobile emission standards. So some big changes around that time. But obviously we still have our problems. We have a lot of fires causing a lot of problems in the western US now. This is a picture from in Reno 2013. And this is Beijing, which I guess we're probably all pretty familiar with air pollution problems in China at this point. Again, also from 2013. And we talked earlier in the class about how it's not, even though there can be some pretty local effects and they can be dramatic, it's not just a local problem. There are some global issues with air pollution, since what happens in China can really affect air quality in California and Oregon, and even what happens in California and Oregon can affect air pollution in the middle of the U.S. or eastern U.S. This is just one example of that. And in fact, the U.S. is the 7th largest black carbon emitter, and it's a problem locally, but it's also a problem globally. So our black carbon emissions, both from forest fires and industry, can have impacts on the Arctic. Reducing the reflectivity or albedo of snow. So snow reflects less sunlight, absorbs more sunlight, and then melts more ice. So it's a problem in a lot of different places. Okay, so the upshot being local consequences, but it's not just a local problem, there are also global consequences. Okay, so the second thing that I wanted to introduce here is kind of give you an overview of what actually is air pollution. And generally it's anything that stays in the atmosphere, so gases and vapors. So greenhouse gases are more and more considered pollution. Carbon dioxide, methane, nitrous oxide are the big three right here. And they come mainly from fossil fuel combustion, burning of biomass and deforestation, and also anaerobic decomposition. That's really where methane and nitrous oxide come from. And anaerobic decomposition happens in places like wetlands, rice paddies, and even in cows. So one of the most important part of Obama's action plan and speech, at least in 2013, and he continues to work towards this, is dealing with measures to reduce carbon dioxide emissions, which the president for the first time referred to as carbon pollution. And this is a pretty big step for it to be referred to as pollution instead of just carbon dioxide or emissions. Okay, so the EPA is now regulating greenhouse gas emissions from power plants, landfills, and then also motor vehicle standards. So we're moving in this direction. although perhaps too slowly for some people. Okay, so greenhouse gases are also industrial emissions of sulfur oxides. This is generally referred to as SOx, but especially sulfur dioxide in coal. And nitrogen oxide. So you might have heard these referred to as the SOx and the NOx. And the NOxes come from nitrogen in fuel and nitrogen gas in air getting oxidized during fossil fuel burning. And we'll talk more about that when we talk about chemistry later in the class. And carbon monoxide, and again, this comes from incomplete fossil fuel combustion or burning in wildfires. Volatile hydrocarbons, another one from spills and industrial combustion. We've talked about some of that, things like benzene, for example, volatilizing into the air. And halogenated solvents, chlorofluorocarbons, sorry, CFCs. And we'll talk more about those and their impact on the ozone layer later on in the course. And then particulate matter is another one. These are very small particles, nanometers to 100 micrometers in diameter. And aerosols are even smaller. They're generally or a smaller fraction of particulate matter. They're usually less than 50 micrometers in diameter. So very small, can stay in the air for days or weeks. So here is sort of an animation of sulfate aerosols, and they come again from coal burning mostly. And you can kind of watch this right here. This is the month, and this is the day or the year here. And this will show you, those are the days right there. And this will show you how sulfate aerosols sort of change over the course of the year. And what you can see in Europe is, if you want to watch that again, you can see in Europe it's a lot higher in the wintertime than it is in the summertime, whereas it stays pretty high. You get to keep that really red color in the US, mostly because of air conditioning units, which Europe doesn't really have a lot of air conditioning if you've ever done much traveling over there. Okay, so this is just a picture that I like showing how cloud droplets kind of incorporate black carbon. So these aerosols that come from burning stuff, they have short residence times, but they have really big impacts where they land. Again, this is the same idea of what we talked about before, but this is an article from a few years ago talking about how shipping in the Arctic may be accelerating ice thaw, just because of the black carbon that it deposits on the snow and ice, causing it to melt faster. Okay, so transport distance from source really depends on the atmospheric residence time. And this is a figure showing you the different particles or different gases and air pollutants that can move up into the atmosphere. And this is a spatial scale showing you how large, like how far they can spread over the distance from 1 meter over space to 10,000 kilometers. And the temporal scale, so how long do they stay in the atmosphere? So this is kind of how far do they travel, this is how long do they stay in the atmosphere, from 1 second all the way up to 100 years. So transport distance really depends on atmospheric residence time. So the higher or the longer it stays in the atmosphere, the further it can go, and the kind of more global its impact. So moderately long-lived species here have regional and urban air pollution issues, smog, things like that. And long-lived species are the things that have contributed to greenhouse gas emissions that have contributed to sort of amplifying greenhouse effect, and also CFCs up here contributing to the ozone hole formation. So the most important sources, really transportation is the largest source of air pollution in the US. It contributes more than 1/3 of carbon monoxide and NOx, and 20% of greenhouse gas pollution. So it's I'm sure we're probably all pretty aware of what a big issue transportation is. It also contributes particulates. In addition to carbon monoxide and NOx, it also contributes sulfur dioxide, carbon dioxide, other toxins, things that are impurities in gas, benzene, hydrocarbons. Urban activity is another one. Again, transportation, but things like lawnmowers, 1 hour of running a lawnmower, at least if it's not a very good lawnmower, can be equivalent to driving for 100 miles. Things like dry cleaners have some sort of volatile substances. Paint fumes, grills, all of this, really. Cooking can have a big impact even on indoor and outdoor air pollution. Fires are another big source, particularly in the western US and other parts of the world where it's a lot drier. These are pictures of the California wildfires in 2007. And you can see, you've probably heard about continuing fires every summer out there. This past one being a bad fire year. And industrial activity. This is the one I think that we most think of when we think about air pollution. Things like smelters, steel mills, oil refineries, chemical plants, paper mills, kind of the list goes on and on. But it's less of a problem now, particularly in rich countries, because these are the things that are really easy to regulate. It's much harder to regulate all of those sort of non-point urban sources and transportation. Dust storms, also not very easy to regulate, but do have an impact. This is a picture of dust blowing from the Sahara across the Atlantic in 2005. And there's a lot of effects of air pollution, a lot of health impacts, a leading cause of cancer. These are just kind of some of the things that particulate matter can have a lot to do with: respiratory illnesses, cardiovascular illnesses, cancer risk, nerve damage. So these are soil contamination, water pollution. So here we're just really looking at this sort of area. And this is a NASA map of premature deaths due to fine particulate matter in air pollution between 1850 and 2000. If you're interested more in this, I can get you more on the sources if you want to know them. Just let me know. You can see bigger problem in some other parts of the world, less problems in other places. There are other impacts of air pollution: damages to buildings, crops, and wildlife, things like acid rain. This is a picture of sort of dissolving buildings due to acid rain. Also, a lot of tree damage back in the 70s and 80s due to acid rain. Ozone also doesn't have very good impacts on trees. And of course, the amplified greenhouse effect, which you're all probably somewhat familiar with at this point, by emitting greenhouse gases, causing us to trap more energy within the Earth and its atmosphere, warming things up. So, sort of sum up this section, we've been impacting the atmosphere for at least 2,000 years, but really dramatically since the late 1700s. We produce it locally, but there are really local all the way to global impacts, and that varies with pollutant residence time. There are gases and particulate types of air pollution. CO2 is now sort of considered a pollutant, more and more so, I would say. There's minimal regulation, but should there be more? It's something that we're all going to have to answer. And many sources, fossil fuel burning really, though, is at the heart of a lot of our problems. And there are a lot of wide-ranging effects from health all the way to ecosystems, trees and plants. All right, so the next couple videos will talk about the structure of the atmosphere, atmospheric pressure, and the composition of the atmosphere. And that's all for now. Thanks.